Okay, so let's say your browser is faced with the task of getting from your computer all the way to videos.adrian.com/networks. How does that happen exactly? Okay, first let's cover our starting point and our ending point. Okay, so here at the beginning, we have your computer, we have a monitor, we have a case, we have a keyboard, a mouse, and maybe even some headphones lying around. This is a computer system because it collects all these components together. Okay. Additionally, this can also be classified as a computing device. That is simply because it can run programs. So even the little TI calculator that you bring to algebra class, while it may seem insignificant, it is also a computing device since it can run programs and some basic math. Okay, so let's get to the end here. And let's say we want to access the web page, videos.asian.com/networks. Okay. The thing is, when we're gonna write to this network, we're gonna be asking videos.asian.com/networks, hey, what's on your web page? Where are you? And this number here, called the IP address, basically tells us, okay, where actually is this? Because when we type this into the search bar, this isn't actually a place. This is more like an alias for the actual address, like a code word, something that humans can remember. Because in the network, they don't really care about the words, the computers. They don't see this part. They just see the numbers. And this is done through the domain name system. It converts this string of words or letters into the actual number that is used. This number is called IP address. And in particular here, this is the IPv4 address. Okay. And one thing about IPv4 addresses is that eventually, with so many computers and devices entering the World Wide Web and internet, these four numbers might not actually be enough. Even if they can go up to 255, which is maximum for each one. Just making a random one here. The computer engineers said that, okay, this might actually be enough in the future. We might run out of these. So they started using the IPv6 protocol, Internet Protocol 6. Okay. And IPv4, notably, this is 32 bits, meaning there's 2 to the 32 possible addresses. And even then, that's a lot. But with the IPv6, they said, okay, this is not enough. We might actually need 2 to the 128 addresses for all the devices that might enter in the future. Okay. So in summary, this DNS turns these human words into the actual numbers that are used in the network. Okay. So now let's cover how we get from point A to point B, because there is stuff in between. Okay. So we have a lovely letter here called HTTP GET request. HTTP is Hypertext Transfer Protocol. This is what dictates most web pages on the internet. Okay, and real quick, just to clarify, the World Wide Web and the internet, they're often used interchangeably, but they're not exactly the same thing. Let's take watching a YouTube video, for example. This would classify under the World Wide Web and the internet. The World Wide Web is usually just these web pages that are a subset of the internet. So you can think of this internet as the umbrella term. Because if you're playing a game with your friend, an online game, that uses the internet, that's not a web page. You're not like accessing friend.com. That's not what you're doing. So that would fall under the internet, but not the World Wide Web. Just making that distinction clear. Okay. And here we have a few options of where we want to start sending our data to get to the end. This is called redundancy. Usually when your English teacher tells you you're being redundant, rewrite this, that's a bad thing. It means there's too many options, too many words, and it's just too long. But in computer science, this is actually a good thing, because let's say we only had one option here, like this. If this computer just dies, then we actually have no way to cross from here to here. So in computer science, redundancy in networks is a good thing because then if this one's out, we still have two options to get to these other routers. Okay. And when we make this connection from our computer to a router, there are, I would say two key terms you would want to know. The first one is bandwidth, which is basically the maximum amount of information you can send at a given point. This is usually measured in megabits per second, which is Mbps, or for slower connections, kbps, k being kilo. And again, that's the maximum amount of information that can be sent at once. And the other one is latency. So let's write that out too. Latency is how long, usually in milliseconds, it takes for the request here to get to this one. You can find how long it takes to get from here to here using a ping request. Okay. So enough about the connections. Let's get to the actual journey of being able to get the web page. Okay. So your browser is going to send this GET request. This is part of the hypertext transfer protocol for web pages. Let's write that out again. HTTP. And sometimes you even see an S at the end. It stands for secure. It means this request is also encrypted. Because if you're at a cafe and you're accessing, let's say, some bank details, you don't want people to be seeing that really, like at the public cafe, since people are also connected to that network. The S can handle that part by encrypting your connection, so they can't see all of what you're doing. Okay. So we're gonna send this GET request, which is basically just asking, "Hey, what's on your website? Tell me more. I'm Adrian. I just really want to see what's on your website." Okay. But these routers, this is too big for them. So what we're gonna do is break them down into smaller parts. So I guess you could imagine folding the letter into parts so that it could fit through these tunnels. Okay, and these smaller letters are called packets. That's a thick stroke, that's fine. Packets. And these packets still have the original metadata. The metadata is things like on the student view, okay, where's this from? This is from Miami, Florida, house 1234. And I want to send this letter to Adrian.com. Destination, where it's from, and the purpose. Okay. And these tiny parts still have that information, still have that metadata. Okay. So we're going to tunnel it through these routers, and we're actually going to end up here at the end. Okay. So let's pass it through here. And just for options, we can pass it through this one, and we can end up here. Okay, they've received the first packet. Let's send another one. We can take different paths if we want, like this. They've gotten the second part. Now for the third part. Okay, and finally the fourth part passes through. And when they get to the end, by the way, this is all part of the TCP process. When we break it down into little parts, and they're gonna hear, the people here, say we've got some little gnomes working, they're gonna work together to just try their best to piece these things together like this. And when they line them up just right, you're gonna see, oh hey, it's from Adrian. He wants to see what's on our website, also called Adrian.com. Okay. Yeah, sure. Let's tell you all about this website. Okay. So they're gonna send you a letter back answering your GET request. They're gonna tell you what's on this website. Okay. So they're gonna do the same thing. They're gonna break up this letter they wrote and pass it back to you through the TCP and HTTP protocols. Okay. Let's pass it through here. You got the first part. You got the second part. Okay, third packet coming through. And now the fourth packet coming through. Okay. You two line them just right, and you're able to get the get request returned. Now you can see, okay, on videos.com slash, sorry, videos.adrian.com/networks, we have this awesome video about networks. And you're able to watch it happily on your computer. Smiley face for that. Okay. And if there were other videos you wanted to watch on this website, we can break this address down a little bit more. Okay, so again, this is the thing you put into the search bar. This is not actually what the computers were using. Okay. They're using the DNS hierarchy as well. Because here we have multiple points. There are a few parts to this address we have to break down. So DNS hierarchy. That's a tough word to spell. Okay. So this .com, this is called the top level domain. This is the stuff you see at the end of every website, like .com, .org, .edu, even .home Depot, I believe exists. That's the top level domain. Okay. And now for the domain name, which is what people buy, okay, that's going to be adrian.com. It's the second part. The third part to this address would be, okay, let me write this out again, .com. This could be adrian.com here. Not very fast with this mouse, sorry guys. Okay. Maybe even google.com, that's right, google.com. .org, and you know the org websites, so I'm gonna write them. Okay, and now further breaking down adrian.com, we would have videos.adrian.com. And the last part here is networks. So now that we've gotten to the part of which website it is, we see, okay, what on the website, like what part of the house, what part of the building are we looking at? This is, you can think of as the room of question. Okay. And the networks page, this is called the path. I hope you enjoyed this video.